Hey, what's going on, guys? So today we're going to be looking at secants, tangents, and angle measures. So basically, the way secants and tangents can look on or inside, or maybe even on the outside of the circle, and then special angle relationships dealing with those types of secants and tangents. So for the first one, we're looking at interior intersections. So we have if two secants or chords, so it touches at 2 points of the circle, that's not the center, doesn't go through the center, then the measure of the angle formed, so at the intersection, is equal to the sum of the measure of the intercepted arcs. So for example, the measure of angle 1, which is right here, is half of the measure of AD plus the measure of BC. Okay, then alternatively, if we look at the measure of angle 2, that's going to be equal to 1/2 of the measure of angle AB plus the measure of angle CD. So basically, the reason why both of these are here, it's really the same idea. Um, kind of a simplified way to think about these arcs too, is that basically it's going to be half of the arc that's in front of it plus the arc that's behind it. So just add those together and divide by 2. So again, going back to here, AD is the arc that's in front of it, directly in front of it. Angle 1 is looking at that arc, and then the one right behind it. Same thing with 2. So you can think of it as the front plus the back, and then divide by 2. So for example 1, it says it wants you to find the measure of angle AED. So AED is this angle right here. Okay. So pretty straightforward use of this equation. So we want measure of angle AED, and it's going to be equal to half of 45 plus 109. So if you add 45 and 109, that is 154. Okay, so 154 divided by 2, multiplying by 1/2 is the same as dividing by 2. That is 77 degrees. Okay, we can look at example 2. So it wants you to find the measure of angle YWX. Okay, so YWX is this guy right here. So looking at what they've given you though, okay, in order to find this and use this idea that we've gone over, you need the arc in front of it and the arc behind it. Well, it didn't give us those arcs, but of course we should still have enough information to find this angle if the question was written correctly. So let's look at the arcs they did give us. They gave us these two arcs, which corresponds to this angle, and if you haven't noticed yet, this angle. It'd be the same. It doesn't matter which one you're technically finding because they're going to be the same measure. But so let's just choose and say that, so we want to find this angle, but the arcs they gave us kind of correspond to, let's just choose this one. Again, it doesn't matter. And those two angles lie on a straight line together, which is a straight angle, so they're supplementary. They add to be 180. So, okay, let me find the measure of angle YWV. So that's going to be 1/2 of 43 plus 81. So add those up. 43 plus 81 is going to go to 124. Divide that by 2, and you get 62. Okay, so YWV is 62 degrees. So to get YWX, we'll just subtract it from 180. So 180 minus 62 is 180. 18 degrees, 118 degrees. Okay, so let's go on to a more simple one, or at least in my opinion, this one's even more simple. So if you have a secant and a tangent, so here's your secant at BA, and then this guy right here is your tangent, touches at one point. Okay, so basically the measure of these angles formed at the intersection are just half of the arc that's directly in front of them. So for measure angle 1, it's half of arc AB. For measure angle 2, it's half of arc BCA. Okay, so two different ways to think about this. You could think that this angle is half of the arc, or essentially that the arc is double of the angle. So both are correct. It just depends on which way you want to think about it. So essentially what I'm also saying is that you could think of this as this whole expression is also equivalent to 2 times measure angle 1 is the measure of arc AB. So these are equivalent whichever way you want to think about it. So let's look at question 5. It wants you to find the measure of angle DEG. So DEG is this angle here. Well, they give you the arc, so all you do is half that arc, 308. So 308 divided by 2 is 154. And that's literally it. Okay, let's go to 6, then we'll move on. The measure of DBC is this guy right here. Okay, they didn't give me that arc. Basically, I need to find this arc so I can half it to get that angle. They didn't give it to me, but it's a circle and it's split up into 2 parts. A circle should add up to 360. So 360 minus 192 goes to 168. So this is 168 degrees. So now we can half 168 and get 84. On to the next, we have exterior intersections. So we've done interior intersections, on the circle intersections, and now exterior intersections. So if you have 2 secants, a secant and a tangent, or 2 tangents, where basically they come from some external point, okay? And all of these are really saying the same thing. So I'm going to put this in a more general way. Basically, the measure of this external angle A is going to be half of CE minus BD, which really just means, in a more general way, that you're doing the half of the big arc minus the small arc. Okay, the intercepted arc, so the one that's in between the lines. So for all these arcs, okay, it's the arc in between the lines. So let's take a look at example 1. It says find the measure of KLM. KLM is right here. Hey, I have the big arc and small arc right in between those lines. So I just do 1/2 of 140 minus 66. 140 minus 66 is 74. 74 divided by 2 goes to 37 degrees. And that is it, guys. Thank you.